Welcome back to Dr. Liu's VCE Physics. Today's topic is light as a wave from the NHT 2019 physics exam. Let's learn together. If teachers, parents, or students see mistakes in my explanations, please give me your feedback. During the refraction of light from one medium to another, the frequency stays the same, while the change in velocity causes a change in wavelength. The question revolves around whether light is a transverse wave. We know that light can be polarized, and polarization is a property exclusive to transverse waves, not longitudinal waves. Therefore, based on its ability to be polarized, light must be a transverse wave. More than just atomic energy level transitions produce electromagnetic radiation. Other methods, such as accelerating electric charges, also generate it. Similarly, accelerating charges are not the sole cause of all electromagnetic radiation, as processes like reoxidation can also lead to its production. Waves fundamentally transfer energy, not mass. For mechanical waves propagating through a medium, energy moves through the material, but the medium undergoes no net displacement. In comparing sound waves and electromagnetic waves, as requested, we find a primary distinction. Sound waves require a medium for propagation and cannot travel through a vacuum, whereas electromagnetic waves can propagate in vacuum space. Monochromatic laser light diffracts upon passing through a narrow slit. The width of the central diffraction peak is inversely proportional to the slit's width, thus, a slightly wider slit produces a narrower peak. Constructed from transparent materials with different refractive indices, optical fibers guide light via total internal reflection. This requires the core's refractive index to be higher than the cladding's. Total internal reflection happens when light within the core strikes the boundary at an angle greater than the critical angle, a condition understood and calculated using Snell's law and the material's refractive indices. When ocean waves pass through two narrow gaps, they interfere with each other. At the central point, where the path difference between the waves from these two gaps is zero, constructive interference occurs, resulting in waves of maximum amplitude. A seawall protecting a harbor has two small gaps that allow large ocean waves to pass through, creating a scenario analogous to Young's double-slit experiment. In this analogy, the ocean waves behave like light waves passing through the slits. By analyzing the interference pattern produced by the ocean waves, we can use Young's equation to determine their wavelength. With both ends of a line fixed, a standing wave can be produced when the line is vibrated. The simplest of these is the fundamental standing wave, for which the distance between the ends is equal to half of its wavelength. To represent a standing wave visually, one typically draws two lines, a solid and a dashed line, to depict the maximum displacement of the oscillation. Since the standing wave is formed between two fixed ends, the wavelength of the fundamental mode is twice the distance between the ends. If the speed of this wave is known, its frequency can then be calculated using the equation relating speed, wavelength, and frequency. Accounting for 19 of the total 130 assessment marks, the light as a wave section makes up 14.6% of the assessment. It is comprised of 6 short answer questions, collectively worth 6 marks, and 3 multiple choice questions, worth 13 marks. If you need my help, You can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.